everyone, welcome back and let us discuss one more question. And this one is from rolling. Again, not that much loaded, but yeah, this is going to teach us something. So let's start with question. There is a non-uniform ball और non-uniform ball का मतलब आप समझते हो ball जिसका mass uniformly distributed नहीं है. Done है. So it is like this. So its center of mass won't be at its center, rather somewhere else. Okay, and this rolls from rest. So here this ball is at rest. ठीक है, and this rolls from rest down a ramp. So this is ramp, this incline, and onto a circular loop of radius r. This incline is getting continued into a circular track, right, which has a radius of a small r. The ball is initially at height h above the bottom of loop. So let's talk about this. Bottom is treated at h equal to 0. Okay, at the bottom of loop, the normal force on the ball, if the ball is here, normal force acting is 2 mg. ठीक है, moment of inertia is given this much, we have to calculate beta. So first thing first, what is going to come in our mind, can we use conservation of mechanical energy? Because if the body is rolling, there must be friction on the surface, and if there is friction, earlier in all cases, what we have done, whenever there is friction, we don't conserve mechanical energy, then we simply write work done by all forces is equal to change in kinetic energy. डन है. बट इन केस ऑफ रोलिंग वी कैन डू, व्हाई? बिकॉज रोलिंग में आपको पता है व्हेन समथिंग इज रोलिंग ऑन द surface, relative velocity between its contact point and the surface will be what? Zero. And since relative velocity is zero, relative displacement is zero, and hence work done, which is force into displacement, will be zero. ठीक है. So while a body is rolling on the surface, friction will do no work. We can conserve mechanical energy. So mechanical energy at point 1, let's call it point 1, and let's call it point 2. Mechanical energy at point 2, we can equate. Then further, अब यहाँ से सोचो आप, it is coming down, it must be coming down with certain velocity, and it must be at the same time rotating like this with omega, such that v equal to omega r. This is the condition of rolling, right? Because this surface is at rest. Done it? So this point of contact should also be in rest. It means whatever this point has velocity because of translation, same velocity this point should be having because of rotation. So v equal to omega r. Now let's talk about energy conservation. So E1 को आप क्या लिखने वाले हो? E1 को आप लिखोगे at that point it is in rest, right? So only potential energy, and that you will be writing as what? अब देखो यहाँ पे certain assumption given है, h is far greater than r. इसका क्या मतलब है? इसका simple मतलब ये है कि this height r is what? R is the radius. So its center of mass must be somewhere here, let's say. So it won't be at height h, it will be at height somewhat greater than h, but that somewhat greater will be very little, that we can ignore it because this h is far greater than r. So we can treat like this ball initially is at height h, so mgh. Now second point पे अगर आप इसकी एनर्जी बताते हो, तो again here we can treat it like it is at height h, because its center of mass height from this will be very small, right? It is almost like it is behaving like a point particle. ठीक है. So E2 पे potential energy 0, यहाँ पे kinetic 0 था. Kinetic will be what? It will be both translational and rotational. So you will be writing half mv square plus half I omega का square. ठीक है. So we can do E1 equal to E2, but for that we need one more thing. I mean, to solve and get the answer of beta, we need the value of velocity. So we can use dynamics for the circular motion. ठीक है. So dynamics meaning writing force equation. So if something is going in a circle, it means what? There must be net force acting towards the center, and that net force must be equal to mv square by radius of that thing. ठीक है. So what will be the radius of this thing? I mean, this hole is small r, and somewhere here this is capital R. ठीक है. So अगर रियल सेंस में रेडियस आप लिखो तो आप बोलोगे r माइनस आर, सॉर्ट ऑफ. ठीक है. बट सिंस अगेन इन द अप्रोक्सीमेशन assumption it is given that r is your far greater than that of capital R, so we can say that this radius is nothing but small r. So यहाँ पे आप क्या लिखोगे? mv स्क्वायर बाय r. अब आप देखो नेट फोर्स टुवर्ड सेंटर क्या होगा? n, that is 2mg, and then down, that is mg. So 2mg minus mg लिखो आप, and this is your how much? mv square by r. ठीक है। सो मास को हमने स्मॉल में लिखा है, सो स्मॉल में ही लिखो। अब हमें क्या दिख रहा है, वी स्क्वायर इक्वल टू आर जी। नाउ वी कैन सॉल्व इट एंड गेट द आंसर। सो आप सॉल्व करो और आंसर को निकाल लो। सो इवन क्या लिखोगे, एम जी एच, एंड दिस इज इक्वल टू हाउ मच, हाफ एम, वी स्क्वायर को क्या लिखोगे, आर जी, प्लस हाफ आई, आई को भी यहीं पे लिखती हूँ मैं, या फिर अल्फा क्या था, बीटा समथिंग था, राइट, बीटा एम आर स्क्वायर। सो लेट्स राइट इट, बीटा एम, एम को स्मॉल ही लिखा है मैंने तो चलो लिखते हैं, बीटा एम आर स्क्वायर इंटू ओमेगा स्क्वायर। ओमेगा और वी का हमने रिलेशन देखा था, वी इक्वल टू ओमेगा आर। सो ओमेगा को वी कैन राइट लाइक वी स्क्वायर बाई आर स्क्वायर, और वी स्क्वायर को हमने अभी अभी क्या लिखा है, वी स्क्वायर को लिखा है आर जी। सो यहाँ पे आप पुट कर दो आर जी। सो आर स्क्वायर कैंसिल हुआ। अब यहाँ पे आपको क्या दिख रहा है, टू जी एच, एम को हर जगह से कैंसिल कर दो। दिस इज आर जी प्लस हाफ बीटा आर जी, राइट। ठीक है। सो व्हाट विल बी द थिंग, जी को भी आप कैंसिल कर सकते हो हर जगह से, यस। सो दिस इज टू एच इक्वल टू हाउ मच, दिस इज, आर को कॉमन ले लो, वन प्लस हाफ बीटा, राइट। दिस इज व्हाट वी आर गेटिंग। सॉरी, हाफ मैंने क्यों रिटेन किया, क्योंकि टू को तो हम उस साइड लेकर गए, सॉरी, नॉट फ्रॉम हियर आई विल बी रिमूविंग, from here let us remove it. ठीक है। So this is basically 1 plus beta, right? So our we were asked to calculate beta, right? So 1 plus beta तुम्हारा कितना है, 2h by r. So beta will be equal to how much, 2h by r minus 1. So what should be the answer, 2h by r minus 1. This should be the answer. Let us check for it. Yes, that is your answer. So I hope you have got this question. I hope you understood all the concepts required in here. But if you have any doubt, you can always let me know in the comment section. Thank you. Bye. Take care.